Hello, and welcome to Running the Digital Thread from Engineering to the Operator and/or Maintainer. My name is Christina Bergling with Global Publishing Solutions, or GPSL. At GPSL, we are content management experts. We like to take complex problems and create simple solutions. You can find out more about our company at gpsl.co. Before we talk about what the digital thread is, let's talk about the problem, about why you would need a digital thread. The problem is that downstream content, be that service content, technical manuals and illustrations, or training, is disconnected from the engineering content upstream. They are maintained in separate systems, creating stovepipes or silos. I'll use an example from my own personal experience. In a previous life, I was a technical writer and a trainer. I worked for a certain defense contractor that will not be named. They were transitioning a missile defense system from being mobile to being stationary. So basically it was a complete redesign of the system. I came on board to transition their technical manual to XML for that system. I set them up to write the tech manual in XML in Mil Standard 40051. We were authoring in Arbortext and storing content in Windchill, so we were working in an established standard with clear guidelines, and we were using good tools. However, all of this existed on an island. It had no connectivity to the engineering data for the system that was being redesigned. The writers, including myself, were in an isolated lab separate from the engineers in the other departments. We were also subcontractors on the project, so our clearances were not hosted by the company. The system was being developed in a classified lab that we had no access to, and the engineers were in that secure lab most of the time. We couldn't even really physically stalk them to get the updates we needed. We more had to rely on these engineers to stop scrambling to get their own jobs done, to remember to tell us that we needed to update our content that they were not fluent in. Needless to say, we missed a lot of changes and updates. More than once, the tech manual did not match the current configuration of the system. The military customer was supremely displeased when the content in the system did not match at Valvair. So that's the inconvenience and consequences of disconnect for the technical writer in the process. That does not even consider the ramifications for the end user, the operator or maintainer or service technician who might rely on accurate content to perform their job daily. Depending on that job, not having the right information could cost time, money, or even life. So we're talking about the digital thread today. Well, what is the digital thread? The digital thread is connecting the engineering data for a product to the associated service or training content. So we're linking the design drawings and bill of materials to the documents and illustrations delivered with the product or used to service and train on that product. I'm going to warn you, I'm going to show you this image more than once, and it comes with a caveat. This diagram is a very simplistic, straightforward rendering of the digital thread concept. You might see a flow this simple if you were implementing a brand new project for a brand new product in all Windchill and PTC software. In the real world, you might be consolidating and reconciling multiple PLM systems. You might be ingesting logistics or LSA data and also pushing data back out to those systems. You might want to associate attributes or metrics from an external system to the objects. There are a lot of pieces that can be included or configured along the digital thread, but for the purpose of this high-level conceptual demo, we're going to keep it clean and simple. So the thread starts with engineering. Engineering puts CAD and parts data into the Project Lifecycle Management or PLM system. That data might be managed in Creo Illustrate and stored directly into Windchill. It might be ingested from another PLM system. It might be uploaded via a step file or even a spreadsheet of parts. How the data comes in and what attributes and metadata it maintains is configurable. But the engineering data goes into the PLM system. From that engineering data in PLM, we get the engineering bill of materials, or EBOM. The key to initiating the digital thread starts right here. From the engineering bill of materials, we create one or more service bill of materials. The service bill of materials allows you to create service parts associated with the design parts in the engineering data. Then you can organize them to reflect service rather than design. You can use applicability for different site configurations. You can group parts into kits to reflect how they would be ordered and delivered for service. You can create new end items or buy parts that are not included in the engineering design. At this point, we can also generate parts lists from the engineering data. From the service bill of materials, we can associate the actual downstream content, service content, technical illustrations, training content, any of these downstream artifacts with the parts. This creates an impact chain where for each part we can see the impact on downstream content. We can perform impact analysis to see how much a design change costs downstream. Then, from the service content that is now associated with the service parts, which are associated back to the design parts, we can publish and deliver our outputs. So the content that is now connected all the way up to the source engineering data gets delivered to the operators and/or maintainers of the system itself. Since it is being fed by engineering data, it is more accurate and up to date. The digital thread, all of this associativity and linking, comes from creating that service bill of materials from the engineering bill of materials. So what is this SBOM doing for you? Why is it so important? It does create that link to the engineering data, but it also allows you to reorganize the data from a service perspective. How a system is designed is not how a system is serviced or how the content for operating, maintaining, and training on that system is written. The service bill of materials allows you to stay connected to the engineering source while accommodating the actual purpose of the content. For former tech writer me, having the SBOM means that I am able to associate those parts with my content and then get system notifications when I need to make changes. It means I don't have to put donuts in the break room to lure engineers out of the lab so I can harass them for updates. It means my content will be accurate and up to date and won't come back bleeding with red lines from valve error. But more important than that, it means my consumers, the system operators and maintainers, are getting accurate and up-to-date content that saves them time and helps them do their jobs better. Now that we know what a digital thread is theoretically, let me walk you along the digital thread in Windchill itself. The engineering data is here in Windchill stored as part objects. In this particular case, these parts were loaded from a spreadsheet. However, as I said, the engineering data can enter Windchill in multiple ways. So I find my end item, the golf cart, and launch the Service Associative Part Structure browser. This browser is where we visualize the engineering bill of materials. You can see the EBOM on the left and the service bill of materials, or SBOM, that has been created from it on the right. This column of icons indicates the associativity between the two. A green check mark indicates that an equivalent part exists either upstream or downstream, and the two are currently synchronized. A yellow triangle indicates that an equivalent part does not exist. In this case, I have created service kits on the SBOM that do not exist in the initial design. Then this clock icon indicates a change has occurred and the parts are no longer in sync. So this leg part on the EBOM has changed. This change is then reflected in the SBOM, indicating that a change has happened to the design part and the service part needs to be updated to match. If we open the updated service part, you can see that Windchill indicates at the part name that it has a change pending upstream. If we go to related objects, we see that this part is included in a parts list. If we open the parts list, we can see that the leg has been flagged as having a pending upstream change. So the change from engineering is reflected in the SBOM, on the service part, and in the parts list where that part appears. If we go to where used on the parts list, we can see that this parts list appears in an information structure and a publication structure. An information structure is a way to organize product data in Windchill. You might decide to organize your product by systems. In this case, if we look at the leg system, we can see that it has been configured to be impacted by the leg part, both the design and service versions. Since there is a change pending on these parts, that is indicated on the information structure as well, again notifying us that a change has happened upstream and requires updates here. The same is true if we open the publication structure. Publication structures are your actual publications, your books that you will publish and deliver out to the field and the users. Here, the section for the leg system has again been set to be impacted by the leg part. Since these parts have pending changes upstream, the publication structure and the affected sections of it are marked as needing to be updated. So the system has taken that change that started in engineering and propagated it down from the engineering bill of materials to the service bill of materials to the service part to the parts list to the information and publication structures. This brings a change all the way down from engineering to the content owners who will update the content and get it delivered out to the operators and maintainers who need it to work on the actual system. So we've walked the digital thread through the system just by clicking through the linked objects. Windchill supports this thread with workflows. You would not need to start at the EBOM and trace the change down. I just did that to show you how all of the pieces are connected. When a change is created in the system, it initiates a workflow. That workflow provides the responsible users or user groups with notifications that changes have occurred upstream and updates are required. So someone will be notified by the system that a part has changed that impacts their technical illustration or content section or training course. Once we have the digital thread running from engineering data through the content to delivery in the field, we can add feedback into the loop. Operators and maintainers on the system can create problem reports. If that problem report concerned an actual part, it would initiate a change at the engineering level that would then trickle down to the service content. If the problem was instead with the service content, it would initiate a change lower in the workflow, starting at service, since it does not impact engineering. This allows feedback from the field to become updates to the content, allowing the maintainers and operators to communicate what they need in their content and their system. Now that we've made our journey along the digital thread, we're back at my basic diagram. Let's walk through it one more time with my missile defense system example. Let's say the engineers have received feedback from the field that the satellites installed are not sufficient and need to be replaced by a new model. That change is made in the engineering design, in the CAD, and parts data in PLM. That change also updates the engineering bill of materials with the new satellite. The change in the EBOM causes it to fall out of sync with the service bill of materials, so the SBOM is flagged with pending upstream change. That change trickles down to the service satellite part, or assembly of parts, in the SBOM, and the parts list that the part is included in. The change also pushes down to the information and publication structures and their children impacted by that changed satellite part. Here, much younger tech writer me gets that wonderful notification telling me I need to update the tech manual for the new satellite part. When I make those changes, and they are approved through QA, I republish my tech manual and push it back out to those operators and maintainers so they can successfully run the updated system and continue to keep us safe. I've said all of this to explain the concept of what the digital thread is. Why is this important? Why would you want to implement a digital thread? Most simply, it's about getting access to the correct and most accurate data. When you have access to that data for your service content or your training content, when that data is being delivered out to your operators, maintainers, trainers, service technicians, you start to see them saving time and being able to do their job more effectively. This has been running the digital thread from engineering to the operator and/or maintainer. Thank you for your time. Please feel free to visit our website at gpsl.co.